We will now embark in the practical aspect of all the graphics that I've been mentioning to you in the first part of this video. And for that, I've uploaded a worksheet for you that you are seeing here. And you can go through them. There are certain questions which are relatively simple to understand that you can go through. But I will go through this worksheet where I'm going to do a pair plot with you based on these variables. I'm going to expect you to interpret that, which is quite simple. And if you have any queries, you can ask me afterward. And then I'm going to explain to you how to do parallel coordinates as well. And for that, I will explain to you that you need to scale your variables. And the next thing is we are going to do mosaic and stack displays. And we are going to focus mainly on one of these. And I'll explain to you which one I'm going to use afterward. And then the rest you can do it yourself. And then you have a mosaic plot that I'm going to do with you. And that's going to be all for that exercise. And we are going to repeat the same thing in Python. We'll start the work in R and we're going to repeat the same thing in Python. So I'm not going to go into that again and again. So I'm going to go over these now. And the rest, there are certain things that you can adapt and change and play around whenever you want. So let me just close this and get into what I want to do immediately. So first of all, we want to load down our packages in R that we intend to use. All right. So we are working with different packages. So let me just mention to you what are the different packages that I'm going to use. So for example, we are going to use first of all the library tidyverse that you have already heard about before. The advantage with tidyverse is that it includes different functions like read underscore CSV. It includes deploy R. It includes where you can use mutate that we will be using later. And then you have ggplot2 is also included in that same package tidyverse. So that's one of the advantages, that when you're loading tidyverse, you can get all of these, and then there is no need for you to load ggplot2 separately, if we can say so. Okay, because this today we are going to be interested in other libraries. For example, there will be a library called ggali that we are going to use, and that purpose of ggali is to obtain G pairs. All right, we are going to use that for to run G pairs, which is basically pair plots, as you would have already guessed. And then you can also do parallel coordinates with that. Okay, through the function gpar code. Okay, so parallel coordinates with this. And then we will load another library, which is VCD. This library is meant for one purpose mainly. It is meant to run the mosaic plot for categorical variables association. That's one. And then we will need the library plotly. Why would I want the plotly? It's especially because when we are going to do the parallel coordinate, I might want to do an interactive part with regards to parallel coordinate that you will see later on. It's not worth mentioning the details right now. So we are going to use that for the parallel coordinates code. Okay, and then we will need another one, which is the scale. So excuse me here. There we go. So we will need another one, which is the scales library. What is the purpose of this scale library? It is to rescale and to apply percent, to use the rescale function, obviously. As you would recall, the parallel coordinates, we need rescaling, and also to apply percent form as well. We can use that for these different function, right, to obtain the percent format whenever we are drawing our graphics. These are the different things that we might want to load. Now, the only issue that you have here is that I'm not sure if you already have these libraries installed on your computer already. If this is not the case, I'm going to ask you to type down install. If this is not the case, install the packages. You can do them one by one, just like you did here, one, two, three. So you will have installed the packages one here, install the packages for tidyverse, install packages for Gigali, install the packages for VCD, or you can all at once put them all together in a single one, which is going to be tidyverse if you don't have it, and then you put comma, and then you're going to put Gigali, and it goes on like that. But I'm going to skip that step here for me, but I'm just mentioning it for you. Any package that you don't have, you're going to include it in install the packages and execute that before you come and execute these. Otherwise, these won't run. Okay, I repeat, if in case you don't have these, you will need to run these install packages command as you are seeing. But for me, I already have it normally installed, so I'm just going to skip that. I'm just going to put everything, but then I will put them in a comment just for the sake of revision. Whenever you are revising here, you'll be able to see what's going on. So let me just put that here. So that is executed only if you do not have it already installed. For my case, I already have installed. That's why I'm not going to execute them, and I put them as a comment here. Otherwise, it's not necessary. So I'm just executing that. So I'm loading the libraries. That's the first step. So maybe to make it a little bit uh, nicer, I will start by saying, okay, step one, packages. And let me do the data import in here itself, data import. Okay, I'm going to do these all at once. Now for the data import, you can use the function read, but before you read function um, read underscore csv, maybe what would be of interest is to set your working directory. As you would recall, in all the work that you want, it's good that you have those working directories set. I already have my path ready, so I'm just going to copy and paste my path for you. It's going to be obviously a different path that you need to set. And remember that when you're loading your working directory, change the backward to forward slash. So you just need to find that path where your file is located. Remember that in the set working directory, you do not put the file name .csv, please. It's only the location of the folder where your file is found. That's all it is. Okay, so maybe I will save that as mm, maybe I will save that somewhere here, and I will put it lab solution workings, so that I don't lose this that I'm working on. Now, next, we want to read the data, and for that, we have already set the working directory. Let me just execute that first of all. And the next step is to read your CSV file, and we'll give it the name of df. Uh, and then we'll say read underscore CSV because we are using the tidyverse package. That's a specific function, by the way. Otherwise, you would have had to use read.csv. But I'm using read underscore CSV just to be able to work with the table, as you would have recalled in my previous lectures for a different module when we're talking about table. A table is The table is a just a sort of modern data frame that well, prints nicely. Okay, that's what it is. That's what a table is, and we can get that through read underscore csv. And I just need to put the file name. For the file name that I've uploaded for you on Google Classroom is this. Here we go. So this is the file name. So ensure that the file name is written exactly as it is supposed to be written. So I'm going to execute that and just check if everything is fine. The next step would be if I want to know what's going on. So here you know that there are 400 rows and 12 columns with characters variables like segment, channel, region, product, etc., etc. And you also have customer ID and so on, which are numerical here, a double basically. But bear in mind that you see that segment, channel, region, product tier are all characters, and they might have to be changed because we don't want to work with these as character variables, and we might want to change these. So we will do that in a moment. But before getting into that, let's just give a quick statistical summary. And for that, we are going to do summary of df. And with the acute summary of df, you can already have an indication of what's going on. But obviously, as I mentioned to you, we do have some issues here because, for example, here you will see that there are certain, even churn itself is meant to be categorical, not quantitative, as you see here. You don't want a mean for churn. It's a 0, 1 variable, so you might have to change these things, and you will see that there are character variables that needs to be changed here. So let's go and fix these data types. We do have some issues with the data types. We'll fix that. That's very important. The data set contains both the numerical and the categorical variables, but when R is importing the CSV, it is treating these categorical variables as character, as you are seeing. So for plotting and grouping, we often want them as a factor rather than wanting them as a character variable. So why factor? Obviously, because this is category and not a free text. Okay, so normally for plotting purposes, you don't want to have these characters. And if you are doing a bar chart, for example, with regards to region, obviously the bar chart will assume that it is categorical in nature, but not character in nature. So we are going to work on that by doing this. Let me just come here. We are going to use a pipe operator here, and we will say df. We are going to do some amendment to df using this pipe operator, as you would recall. Excuse me, where is it? Dot. Here we go. I'm just going to copy and paste that just in case, because I might be using it again later, but I'm not sure though. Let me go ahead. So df, and what do you want to do here is that you want to use to apply a mutate function on df to modify your different columns. So you would recall maybe in the last year when we were doing that, we were modifying our columns. So you want to, excuse me, here we go. We want to apply mutate here, and then when we talk about mutate here, we want to modify certain of these. For example, you see integer here is double. We might not want the customer ID to be double, because you might work with this customer ID later, because especially when we are working with how do we say, parallel coordinates, that might be of interest to us, and we don't want these double to be there, and we might want to change that first of all. So we're going to copy this customer ID. So there was no need for me to copy this anyway in the end. So customer ID, we're going to do that, and we are going to say that customer ID is as integer, and we are going to put the same thing, customer ID here, and we put a comma here to continue. That's the first thing. Then we want to change several things. We want to change segment, we want to change channel, we want to change region to make these become categorical in nature. So what do? Is that we will say segment equal, we will say channel equal, and we will say region equal. These are the different things that we want to work with. So maybe I'll align these together to make it a little bit neater. It's okay if you put the space, doesn't matter. And then here we will use the function factor to convert these different segments. So quickly, just give me a second with you. I'm just going to open the file from Excel just to show you something quickly. Just give me a second with you by the time it opens. Yes. So here we go. You will see that segment, region, and channel, they are all already named, call, value, etc., and they are referred as character. So there is no need for me to add additional arguments in that particular factor to describe what the different levels are. Normally, if these were numbers, for example, if these were numbers, that is, the region was just like churn, for example, I might have had to rather state what each represent, the labels represent. I will do that afterward anyway. But here there is no need for that because it will automatically be able to detect the different levels itself. So I'm going to write segment here. Don't forget the comma. I think it's very easy to work with that setting, as you would see here. If you could start to use that setting a few times, you will see that becomes very easy to work with that. And especially that you have started working on it before. So for the first time, you might see it a bit tricky, but afterward, you will see that this is far more convenient to work with. Okay, let me just put the mutate here. Um, and then what is the next step? So segment, channel, region, and then you also have the product tier, by the way. So the product tier, let me just check the product tier quickly. Um, where is this? The product tier, we again have it as it is here, premium plus, etc., etc. So data filter, let me just check something quickly. So basic plus premium. So we are going to do the same kind of thing here. So product tier equal to, and then we will do factor of product tier. But the only thing that you have to be careful in this particular setting here is that when you are changing the data type, like segment, channel, region, they are all nominal in nature. Nominal. But product tier, basic, premium, and plus, they are not necessarily, how do we say, nominal in nature. These are nominal. East, west, you can't say that east is higher than west or whatever it is. There is no intrinsic order in these levels. But here there is an intrinsic order, and it is good that you do describe all these, especially as I said to you, for the purpose of plotting later. Things becomes far easier and you don't get issues when you are seeing the levels being displayed in whatever direction you want. So if you want the levels, you will say that the levels is equal to C, and we will put the different levels. So the different levels are, let me go back to the Excel. You will see they are basic. We write it down as it is here, basic, premium, and plus. Okay. So we'll put it in the order that they are supposed to appear. There are three levels here. So the first level is basic. Then you have plus. Then you have premium. We ensure that it is written exactly as it is, not no caps lock missed or anything. Everything is there. And then when this is done, you need to add another argument to this function where you will say ordered equal to true. Ordered equal to true. All right, that means that it is a categorical variable indeed, but it is an ordinal variable mainly. Okay, that's important. The last thing that I want to do is to work with this churn um, 0 1 variable. So first of all, instead of calling it churn 0 1, I would rather call it directly churn. That would make it easier for me to work with later. And then I will do factor as I did earlier, but then I need to write this down exactly as it is here, churn 0 1. And then there I need to be careful because it is 0 1. So 0 and 1 means something. 0 means not churn, and 1 means yes, a client has churned. So what happened here is that we will need to describe the levels first, just like we did above, and we will state what are the levels that the data has, just like we did here, same thing. But the only difference is that we don't need to use this label of ordered or whatever, but we don't need to use ordered, sorry, but we will need to use labels to describe the different levels that you have here. What are the different levels? The different levels is, first of all, 0 represent no use. Write in the order that you have written here. And 1 represent yes, churn. Oops, excuse me. So 1 represent yes, churn. So that's basically the mutate function, what we want to do, and we can execute that quickly and we'll see what will happen. So let's have a look at the df. We can do something that we call glimpse of df that shows the structure of the data. So it's a bit like str in the base R version. You will see that here things have worked so well, like it has become integer. This is no more a character. This is factor, and this one is an ordinal variable. This one is a factor, as you see, and it is by yes and no. It is no more as 1 0 or 1 0 whatever. So you see the churn 0 1. We kept it as it is, but there is a new one now that is given. Okay, so that is a glimpse of what's going on. So the glimpse here is showing you the variable names, it is showing you the variable types and first few values that you have in the data set. So you can do a summary of df again if you want, just to better have an idea of what has changed. Here we go. Now we don't have the same thing that we had earlier here, like character or things like that, but we are having correctly the model category, for example, is basic, things like that. Okay, so that's the first step that we want to do. Our next step now is to draw the pair plot. So let's go ahead with that. That is also referred to as a scatter plot matrix, as I told you earlier. So here the pair plot is going to help us explore multiple numerical variables together. It will create basically a grid where you will have diagonal and off diagonal, as explained to you earlier. And the diagonal will give you the distribution of each variable, like the histogram or a density plot, things like that. And then the off diagonal will give you the scatter plots themselves with regards to relationship between two variables. We will also try to color points by segment to see if these segments behave differently. So that's the idea behind. And you need to ensure that you're working with a list of numerical variables. To make things a little bit easier, we are going to create that list of numerical variables, and we are going to use the pair. We are going to run the gpairs directly on this list of numerical variables. So let's call it var num, because remember that for the scatter plot, it's only for numerical variable that you are going to use a scatter plot. Okay, so varnum, and then this means that you are creating a numerical list of numerical variables, and in the list of numerical variables you're going to put down all the names of the variables that are of interest. So you will see in the worksheet I mentioned to you that there will be income MUR. So we'll need to write down the names as they are here. So as they are here, numerical variable that is income. Then you have visit last 3 months. Then you have spend last 3 months, MUR. Then you have tenure, you have satisfaction here. Let me just put this down here so that you better see what's going on. So you have satisfaction, you have tenure months, I forgot here. Okay, you have tenure months. And then you have age as well. So normally we are expect to have six variables. 1 2 3 4 5 and 6. 1 2 3 4 5 and 6. Six variables that you are seeing here. Let's execute that first before we are going to draw the pair plots. Here we go, we got this done. So what are we going to do now? We can run a function called gpairs, ggpairs rather, not gpairs, but gpairs. And that function is the main function from the library ggali. that will build the pair plots. You remember the library Gigali? That's going to be the function that we are going to use from that library that will build the pair plot. And we'll give it a name. So let me give it a name. So we'll call it, excuse me. So we are going to call it P pairs, pair plots, P pairs, and sorry, yes, P pairs, and then GG pairs, and then when you are running these GG pairs, you it's a bit the same syntax that you have done in ggplot normally. So you will write df. Maybe what I will do is come here. So df is one thing. Then you will need to state the columns that you are going to have. Now, that is, you tell ggpair which columns, that is, which variables to include in the data. This is done by saying columns is equal to, and then we are going to put that name here, varnum. That's one of it. And then the next thing is to put the aesthetics, that is the visual mappings that you have. And in the aesthetic function here, you will put different information like the color. You remember that I mentioned to you that you want to separate them by segment. So we will say color is equal to segment. And then there is something else also important, is because you will have quite a number of plots, you might want to use transparent dots or less transparent dots, especially to avoid overplotting. So if you want to avoid overplotting, you can put a value of alpha which is relatively small, like uh, 0.6, for example. 0.35 rather, 0.6 or whatever it is, something that is small. Then you can play around with this if you're satisfied or not. It depends on you anyway. You can just check this out later. Apart from the aesthetic feature, I will also show the in the lower triangle. Basically, I want to show the scatter points, but in the upper triangle I will have other information like the correlation value. There are other quite a number of information that you can obtain. All right. So let's get into the uh, next step here, where I'm going to include the upper triangle that will contain information. So the upper triangle will show correlation for the numeric pairs. And to do that, let's call it upper equal to, because it's the moment that you put GG pairs, there is the upper triangular that you can include information. And in this information, you will put a list of two things. There will be the correlation and the size of the number that is being displayed on the upper triangle, right, part of the matrix. Now that, when I'm mentioning right now, might look a little bit abstract to you what I'm saying, but as soon as this part of the code will be over, you will get a better picture of what I meant when I'm saying that. Okay, so for example, here you will see that you have continuous is equal to, and then in continuous is equal to, you are going to put let me just check that up, and then you're going to put wrap. That's going to be a function. This wrap means that you are going to display the correlation number with text with a particular size. All right, and this wrap will include different information, as I said to you, but it depends on what you are expecting. You will have a size, and you will have an information which will be the correlation. Right, so you can put it as cor, C-O-R, and then the size, which is going to be equal to, it depends, you can play around with this value. You can put 3, you can put 4, you can put 5. Let's put it 3 for the time being, and then they will just see if it works. If it is not sufficiently large, we are going to increase it further, or if it's too big, we are going to decrease it, obviously. Okay, now the other thing is that you will precise what the lower will include. the lower triangular part of matrix will include a list again, as you would have seen here, continuous wrap again. I'll just copy that thing here. But the only difference is that in the lower triangular, I won't have the correlation value, but I will have the points. And again, the size, maybe you have to be careful. I don't want the points to be overly increased. I can keep it as 1, or I can even decrease it to 0.8 or things like that. You don't want it to be 3 times what it is supposed to be. Text, you can allow yourself, but the points, if they are too big, that would not be very nice. Okay, so that's part of the thing in terms of the aesthetic feature that you want to include in here. The next step would be, we are not yet over, we have to put when we are going to draw that graphic here, if you are not going to change the theme, you will have a sort of grid lines that will run around all these different um, panels, and it's not very nice. So what we want to do is to have a clean black and white base theme, and that is going to be done by with the plus as you are used to, and we are going to say okay, plus theme, and we want it a black and white theme. You don't want something else. Now this step that I'm doing here is optional. There is no need for you to do that. You can give it a try, by the way, just for the sake of time. I'm not going to do it, but you can give it a try just by running only this, okay, without going into that step here if you want. But again, there, this is optional. So what I would suggest to you, when you're doing this code, you run it up to here, that's all, and then you are going to add this here to see the difference that it brings, and then you are going to add what I'm going to explain you now, so that you see the difference, how it looks like. Okay, so just run that first, and then you are going to run that all together, and then you are going to run what I'm going to explain now. The next thing I want to talk about is to improve the theme again. So we're going to put theme where I'm going to put the legend. I'm going to state where I want the legend. So there are different information, like you have a legend at the bottom, you can have legend wherever you want, okay? Normally this applies if you have a legend normally, but if you don't have a legend, then what you can do is, let me explain that quickly. If this applies, normally it may not apply in our case. So we say legend position, then if you have legends, then you can put it at the bottom, you can put it at the top, you can play around with this legend wherever you want. But in our case, we don't necessarily have the legend, though we do have a legend, sorry, because we will have the points differentiated by segments. So we'll just stay, we'll leave it as it is for the time being. Okay, let me just erase that. Let me just erase that for the time being, and I'm going to run it without this parameter just to see what it gives us. And if there is a need to change that, we are going to change it accordingly. So we have a panel dot border which I want to include, and this panel dot border is what? That is for each cell in that matrix, you want the graph or the information to be enclosed within a square box or within a box, all right? So then this is what I'm mentioning here, panel dot border. So you want to write this by taking this code element rectangular, and then you say that you want the panel to be of color black. It depends. If you want it to be blue, you put blue, and then that's one. And the next step would be to um, now yes, let's leave it as it is here, and then the next step would be to remove any grid lines that you might have, if ever there are grid lines that I'm mentioning. You say grid dot major to eliminate any major grid line that exists, and for that you are going to say equal to element underscore blank. And there is the last one, which is a minor grid line that you want to include. Again, underscore. This one is not major, but minor, and you will say underscore blank. So we can now execute all these and print that object display, right? So using p pairs, p underscore pairs, as you note here. So let's execute all these at one and see what we get. If there are modifications to do, we are going to do the modifications accordingly. You see here down, it's giving you a status of the plots, 50% estimated, whatever. So we just wait a little bit more and we'll get it now. So here we go. We have our pair plots right in front of us. Okay, that is our pair plot. You see that it gives you information. Now you may want to change these. If it is too small, you might want to increase these, etc., etc. It's up to you what you want to do. You can just amend certain of these information. So you have a correlation values, for example, here. The correlation is relatively. Let's have a look at all these different information. You will see that the highest correlation seems to be here of 0.108, and by the way, you will see that it put this asterisk here, so that indicates that your correlation is relatively strong for that panel. What does it mean, that panel? It refers to satisfaction, that you are seeing here, satisfaction, and the variable spend last 3 months. Satisfaction in spend last 3 months. So if you look at spend last 3 months and satisfaction, where is this? Yes, this is the variable that we are referring to. All right. Look at it on the other side here. You have spend last 3 months and you have the satisfaction here. That's what it is. The correlation will be the same. Okay. So as it is here, so it's giving you this information here. All right. What is the correlation? This is a little bit higher compared to the others. But overall, you see that in this data, there is not much relationship. Okay. The other thing that you would note is that there was no need for us to bring any legend here because the legend is already described as you see here. You will see the red is defined by core segment. You would let me just show you that quickly. You would have here the core segment, value segment, VIP segment. So you will see that the core segment is giving you a correlation which is negative for visit and income. All right, visit and incomes are negatively correlated for the core segment. These are the different information that you can see. You have value for the VIP segment as well. It is negatively correlated between income and visit for last 3 months. But for the value segment, you can see that the correlation is 0.079. Now, for the core segment, the strongest correlation that you can observe here is the negative 0.472, and you will see that there is a 0.506. So it seems to me, sorry, when I was saying 0.108, it's wrong, excuse me, but the 0.506 is the strongest correlation where you have age and income, where there is this relatively stronger correlation between these two variables, age and income. Okay, so if you want to see what the relationship looks like, here it is. You have here age and income. So you just need to look at it from this side, income and age down there, you see. So when you see this variable age and income, it corresponds to that correlation overall. It corresponds to a core correlation, that is a core segment correlation of 0.506, a value segment correlation of 0.431, and so on. These are the beautiful things that you can get from this plot. And in addition to that, you can see, for example, and the distribution of satisfaction seems to be by not bimodal but sort of multimodal. right? Whereas the distribution of tenure months seems to be overall, irrespective of what segment we are discussing about here, the distribution of tenure months tends to be more or less positively skewed. Same thing for income. That's what you expect income to be positively skewed. On the other hand, for a visit last 3 months, that is a little bit erratic in terms of distribution. Some is sort of unimodal, but for the value segment, there seems to be some multimodality here. These are the different information that you can extract apart from what you are observing already here. Now, that's it for the correlation. I'm just going to close this now and we are going to move on now. Mm, let's close that. Uh, we are going to move on to the next step now, which is going to be. Uh, Let me just check something first. Give me a second review. So we've already done that. There's no need for me to put the legend here, as I mentioned to you. That's fine. So for the interpretation, I already explained it to you. You will need to have a look at. Let me just run that again. When you are running the interpretation, there are different things that you can look into that you can also check as well. Like here, you can see if there is if a scatter panel here shows a tight upward or downward cloud, that would indicate a strong relationship. This is not that much strong here, but still you get this information. So if there is a pattern, if patterns are curvy, but this is not observed here, that would indicate nonlinearity. Uh, you can see for the variable visit last 3 months, for example, the blue, that is VIP, tends to be on the right hand side. So there are more visits in the last 3 months from VIP people compared to others, things like that. These are information that you can identify as well. So these are the different information. So uh, we can also check for outliers as well, but there doesn't seem to be any outliers yet to identify. Now let's move on to parallel coordinates. Uh, what are we going to do is, let's write this down here, parallel coordinates. And here we have seen that the pair plots shows a relationship between two variables at a time, but the parallel coordinate shows many numeric variables at the same time as profiles. All right. So each row or customer in our case becomes a line, and each vertical axis is going to be one variable. So when the line normally will cross at different axes at specific customer value. Now, important to note that variables are in different units in our data. You have MUR, you have counts, you have months, you have ratings, all kinds of things that you see. And we need to do min-max normalization so that all the variables are comparable on the same 0, 1 scale as I've mentioned in my lecture notes. So first of all, we are going to describe our variables that we want to use here. Let me bring this down. So let me just call it var PC. All right. So we are going to use income. We are going to use spend last 3 months. We are going to use it visit last 3 months. We are going to use tenure months. We are going to use what else? Satisfaction 1 to 5. But I'm not going to use age based on what I gave you in the worksheet. All right. So I'm not going to work with age. So I'm working with only these 5 different variables in that particular context: 1, 2, 3, 4, and 5 variables. So I'm going to disregard age in this particular example. You could include age if you want later. As I said to you, I'm doing that with you. Now you can just play around. If you want to add more variables, you can just do that. Remember that we are working with numeric variables again. We want numeric variables um, in the parallel coordinates plot here. That's important so that our plot doesn't look strange here. We are going to work with these numeric variables, and then we are going to start by running a function at some point in time called ggpar code. This is the function that is going to be used, ggpar code, which is the function that is going to enable us to draw the parallel coordinates. But to be able to do that, ggpar code can accept columns as indices rather than names, all right? Or positions if you want, rather than names. So we are going to use a function that will return the column numbers for those different variables that we are going to work with. Okay, for those different variables that we're going to work with. And to do so, let's run this first. And I don't forget this. Yes, and then what are we going to do? We are going to run a function, and I'm going to call it calls underscore idx. Let's call it that name, call IDs, and I'm going to match the vars underscore pc with names from the data frame, right? So what we are going to get here, we will get the position of the names in the data frame as they are. Even if this is no disorder here, doesn't matter, but it will match these income on what name it is, on what position is it. Is it on the is it the second column? Is it the third column? That is what's going to happen. I repeat, here, ggpar can accept columns as indices rather than names. That's why we need to do that small additional step here. And if you do call idx, you will see that for income, it was a fourth variable, then visit last remember was a fifth, and so on. Okay. So now the next step is we can start by drawing the graph by saying, let's call it PC, parallel coordinate. And in this parallel coordinate, we are going to write down whatever we need to here. So what are the different things that I want to do? Of course, it's a data frame, as usual. That's the first thing that you want to do. And then in the parallel coordinate, I need the column IDs. The column IDs, I'm going to call it column, simplement, columns, and then equal to, and then I will call it column IDs, all right? And then I will put comma because that's not over yet. We are going to do the min-max normalization, and for that I'm going to call it scale, a variable called, I'm going to run the in the parallel coordinated function called scale, and that's not a function but an argument called scale, and that scale argument, so columns is the argument that you have in parallel coordinate, df is the data, and then the scale is another argument that you have in gg power code that enables us to include what type of scaling you want, whatever scaling you need to do. For me, I'm going to run the min-max normalization. That is, it brings all the values of the different variables from 0 to 1. That's the main idea. So we can compare relative high and low or lows rather than raw units directly. And this is going to be called uni min-max. Okay, so the name that we use here is uni min-max for this particular context. All right. Remember, I would like to remind you that in the class test or anything like that, I'm not going to ask you to write codes necessarily. That's not the intent. You're not doing a course in computer science here. But the idea is that you need to understand what these different functions are doing, so that if I give you these functions in a class test setting or anything like that, you should be able to recognize what min-max means and what it is doing at least. But you cannot, I'm not going to ask you to write the codes from scratch. So you should not worry about that if in case this is what you think might be asked. It's not the case. And then you can draw the lines of a parallel coordinates, and for that you can make it then transparent. You would recall if you have, so for that you need to use lines, and then you can play around with this alpha line, make it more opaque, more transparent, things like that. So let's use zero point 0.6 for example, for the time being. Okay, and then if you want, you can just run that and execute this PC only, and you will see that you get something like this. Okay, that's a parallel coordinate that you get. But if this is not bad as such, but there are quite a number of things that you would prefer to have in terms of the parallel coordinate being drawn by segment, for example. And then you will see better which segment seems to be high on which variables. For example, you would want to know what these relates to because it seems to be a bit outliers. What are these referring to? What kind of observations, and whether it forms part of segment, it is a specific segment, rather high on visit last 3 months, things like that. You can get this information here. So, but for that, we need to improve this plot further and remove that gray background and everything and improve that further. So to do so, what are we going to do? We are going to do add the theme as usual. And the theme is black and white, as I mentioned to you. Uh, and plus, next is theme. I just don't want these grid lines as you have seen here earlier. So maybe what I will just do is copy and paste what I've done here. Panel element this. So I would like to remove this here, panel the and then I would add some labels to this function by putting a title, and instead of having something like what you saw earlier, let me just run that. Instead of having something like that value, you would prefer to have it as scaled value rather than value. All right, you want to change that. For example, I come here and I add another argument to it, which is going to be the labs argument that you would recall I've done earlier in previous lecture. All right, so what are the different things that you can do is put a title called parallel coordinates. By the way, these are things that you can also do scale, I would say, by segment. I'm not yet done it by segment. I will show you in a moment. Don't worry. Uh, I forgot something when I'm saying by segment. The columns here, I need to add something else here because I need to put the group. You want to group column by segment. And to group column by segment, sorry, I missed that part here. We need to do that. You need to state what is the column that you want to group by segment, and this is to be able to compare group profiles rather. This is not necessary if you don't want, but if you want it, it has to be done like this. Uh, let's run this. Yes, there is something else I missed here. I need to put down the y title, the y label, and I'm going to call it scaled value, and I will call it min max normalization so that someone understand that this has been done through min max. And I'm going to say PC to run the whole thing. Yes, let's check this again. Oops, let's run this again. Here we go. That is a little bit better now. We can see more information pertaining to what is going on. For example, the blue here, which represent the VIP, tends to spend the last 3 months. They have higher expenditure over the last 3 months, as you see, because they are the one that is up there. And then what else? If you have quite a number of things that you can do is that you look for consistent separation of colored bundles across axes. Like here, you see that the red seems to be a little bit on the high side for span of, how we say, for span loss value, and then the blue is even higher. Obviously, the green tends to be a little bit lower, the value segments tends to be lower overall for span last 3 months. And then for the tenure month, we can't say much about it because it's a little bit all distributed around. And there seems to be also quite a number of more, how do we say, uh, greens, and you will see that the greens are those people. The green means the value segment seems to be the one with the lowest satisfaction here, and they are the one with the lowest visit, things like that, you see, because you have a concentration of those green lines down there. By the way, if you want to even improve this further, you can decrease this to zero point 0.3 to get a better picture also of, if you have it, or if you think that it is a bit too much to understand what's going on, you can decrease that transparency, and you will see even better what's going on here. For example, you see the red is a little bit the middle section, the blue seems to be higher section on spend, and for income, it's a bit all mixed around, though you can see that the blues tends to be a little bit more on the high side, and the green are always on the low side of income, things like that. So there are different things. You look for consistent separation of colored bundles across the different axes. So there are also outliers here, as you see. So but these are sort of individuals. Like this is an individual that is an outlier in terms of his spend. This is an individual. Remember that this line represents a profile of an individual. So that person would have had an expenditure which is in the middle range of the income scale, and he would be a little bit high on the visit for the last 3 months. So he's somebody who has visited a lot in the last 3 months a lot. In addition, he's tend to be the one who has got a high level of expenditure for the last 3 months, and his satisfaction is also high, including his tenure months, which is someone basically who has been in this organization, rather, or in this store for a long time. All right, is somebody who has been purchasing from that store for a long time as well. So this, for example, you can already see a profile of a particular individual going on there. You can identify this individual quite easily. Okay, you get an idea of a particular profile, though you have to always be careful, because sometimes it could also imply that this individual here is the one that has increased to here, but it also, you have to be a little bit careful about that, because normally interpreting the particular profile might be a bit tricky, because for example here you may not be aware of which of these 2 points correspond to that particular line. It could be this point, it could be this point, but obviously when we think about the previous line, we might have an indication that this is the guy that we are referring to with the highest tenure months as well. But as I said to you, we might not be interested in interpreting a particular individual here, except if it is an outlier, as we said. But we have to be careful. Like here, there are two blue lines, so it's not always straightforward to identify which one corresponds to which one. So be careful about that. But overall, you see that there are many, many lines here, and this plot can look quite crowded. So you can also take a random sample to illustrate that better if you want later. Okay, but we are not going to talk about a random sample. We'll stick here to what we have done so far. If you just want a random sample, by the way, it's quite simple. I just give you the beginning, and then you are going to change a few things if you want to do the random sample. I'm not going to get into the details, but I just write it there if you want the random sample. First of all, if you are doing a random sample, what happens is that you will need to slice your data frame. This data frame that you have, you will need to slice it into just use a pipe operator, and you are going to use the slice sample function. It's going to be a random sample that you're going to apply, and you will see that instead of using the 400 customers, I'm going to use only 150 customers. If you want to have a better picture, if you think that this is too crowded, that's the kind of thing that you can do. But instead of working on the current data frame, maybe I would suggest that you put it as DFS, which is the sample DF now, rather than working with the whole thing. And when you are doing a sample, it's always to use good to use something that we call set seed, and you can put whatever value 20 here, but ensure that you use the same value each and every time, and that set seed ensures that you are reproducing exactly the same random sample, and then the rest stays as it is. You're gonna run the same thing, except that you're not gonna run it on the df, but you're gonna run it on df underscore s, and the rest stays as it is. Again, as I mentioned, instead of df, you have df underscore s. If you want to do that, you can do it later. Okay. Now, you will see that here, for example, I was mentioning, you have to be careful to know which line correspond to which line if you are studying the profile. And it's a bit tricky because you can't assume that this line is for this one, or this line is for this one, or even something else down there. Um, to be able to get more information with regards to this parallel coordinate that you have plotted, you can do an interactive parallel coordinate through the package Plotly. All right. So that is what we are going to do now. And Plotly will make the parallel coordinate interactive by where you can hover to inspect certain values, for example, and many brush or select ranges on x-axis to keep only on the axis, rather not the x-axis, but to keep only some lines, rather than having all the lines having here. You can just select only two lines and then see what's going on with regards, because here these two lines, you won't know what's going on with it. So the only issue here is that you have to be careful is that Plotly, normally the function that we are going to use to plot parallel coordinates would be par codes, and sorry, and that function is designed for numeric axes. All right, that is, it is designed for continuous scales mainly. So we want to ensure that we choose continuous scales, but we will try to do something a little bit different here. Is that I would want to, here you see that I've differentiated them by segment, but now I want to have two, that is the two, how we say, churn and not churn being represented, rather than the segment being represented by different colors. I would like to have that. So if you want that, then you might have to do certain manipulation to your codes here, but I will explain that in a moment. First of all, we will use the same vars PC that we have used. Let me just check. You have income, you have spend last 3 months, you have visit last 3 months, you have TNU, and you have satisfaction. These are the same variables that I'm going to run my parallel coordinates. Okay. So what I want to do is, as usual, I want to scale everything to 0, 1. And the scaling of these variables here, you have to be a little bit more careful when you're going to do the scaling here. But again, we are going to use the same principle. I'm going to call it DFTC, parallel coordinates, and I will do DF. Just give me a second with you. I'm just checking something. So yes, let's stick to that. So DFPC, and I will apply this operator again. Where is it? Here we go. And we are going to apply the mutate function as usual to change certain, to change all these variables. and you want to change all the variables that we have in var pc to numeric variables. Okay, here we are not using ggpar code. In ggpar code you can just simply write scale is equal to unimax, but in my case we are going to have to do the mutate before getting into the code, because we are going to use a different function as I just mentioned to you, which is the par codes rather than ggpar. So now mutate, what you want to do here is that you want to change all the variables, and you are going to rescale these variables. Okay, so how can you rescale these variables? So first of all, we are going to say across all of, which is a function, all of the var pc that we have defined here, across all of these, what you want to do within the function across all of these, you want to apply the scale. All right, to be able to apply the scale, uh, you will need to use this tilde function, and then you will say scales, or you don't need to say scales, but rather directly rescale, because we've already loaded the package before. You can say rescale, and rescale, what you will do here is you will include the current column being processed. And the current column being processed means when you go in var pc, you will have the first column, which is income MUR, the second column, which is visit last 3M. So when you're doing this function rescale, you don't want to do it one by one, but you just put dot x. When you put this dot x, what's happening here is that you are considering the current column being processed, and you are applying your rescaling to what? To a range of C, sorry, to a range of C, yes, just a second with you, yes, to a range of C0, comma 1, all right? Where is it? Just give me a second review, there's a small issue here. Comma 1. So what I'm doing here is, let me just ensure that I did not miss any steps. So we have it all across here that ends here. We have a scale, so we miss one bracket here. Okay, and the other bracket is for mutate, so it's good. You are doing what here? You are applying this rescale function to all the variables, and when it is saying dot x, it means that for the current variable you are going to replace it to 0 and 1. That's the kind of thing that you want to do in this particular context, and we are going to run that and see if it runs. Here we go. We can do dfpc just to check, and you will see that all the variables all the variables concerned have been converted to that is the new month, income, last, all these variables have been converted to 0, 1, as you are seeing. Okay. Now the next step is that when you have done that, we can build this interactive parallel coordinates now. How do we do that? I'm just going to call it figure now, and then we are going to use the function plot underscore ly. Plot underscore ly is under the plot leaf function, obviously, and you will need to state what type of plot you want to draw. Okay, for me, I want to say type equal to, and then you will need to mention what types of plot you want to do. For example, I will run par codes, which is the argument that I need to use to draw parallel coordinates. So here, when I'm doing that, I'm telling Plotly, we want a parallel coordinate plot. That's all it is about. And then you have another one, which is the line. Okay, the line needs to be defined. The line is where you're going to put to control the color. Basically, you will have a color for a different line. So here it is important that you remember, as I mentioned to you, we are working with numerical variables rather than categorical. So Plotly generally, when you're doing parallel coordinate, assumes that you are working with numerical variables. So if you are using the line and trying to put the fact to use with churn variable that we defined far earlier here in the data frame directly, that is here, where is it? To use this churn that we have redefined, it may not work. So it is preferable that you work with the um, original variable char01. That's uh, preferable to avoid any problems. Okay. So how am I going to do that? I will say line is equal to list, and in the line, what are the list that I'm going to do? The color is going to be defined based on uh, the color will be defined based on this variable that I mentioned. Where is it? df dollar df underscore pc. Yes. Let me just have a look at the glimpse of DFPC. Give me a second with you. I'm just checking something because it seems that there is something not totally correct here under scope PC. Just do that. Yeah, the churn is here. Okay. So I was worried because I thought the churn was not there. So churn 01 is here, so that's fine. Let me delete that, and we are going to run this DFPC based on this churn 01 that you are seeing here. So what is this doing here when I'm writing this line is equal to list color dfpc dollar churn 01, that is the original variable, not the factor one. So here what I'm saying is that I'm saying to Plotly to use gradient scale automatically. Right, when it says color, gradient scale automatically, so it will choose a color automatically without you worrying about what's going to happen. Okay, then we have to do something else where you need an additional parameter now. That additional parameter would be the dimension parameter. Now, these dimensions parameter, what it does is that it defines the axes in the parallel coordinates, right? So Plotly expect normally a list where each element describe one axis. That is, you have something like, for example, let me just write it separately here, something like list, and then you have label, and then you will put your axis title there. Uh, and then you will put the values which represent the numeric vector for that particular axis title. For example, segment, you would put values equal to segment, and here you will define it as capital segment, for example, capital S segment. This is what normally Plotly expects as dimension. Okay, but you would realize that I'm not going to be able to do that one by one. It will become very lengthy process to do that one by one. There is a fast way that you can do. uh, just for information, if in case you did not really get what I mean, it would mean that I will need to have a list, and in that list I will have another list, which is this. And in that list, I will have another list like that. Excuse me. Huh? So where now I will have, for example, income MUR, and then the values will be DFPC income MUR, and then I would have to say comma, and then list label spend last free um, month MUR, and repeat that process again and again. But rather than doing this the lengthy way, that is going and doing that each and every time, going on like that with another list and etc. for each variable, rather than doing that, there is a far simpler way of doing it. Okay, there is a far simpler way. It might look a little bit complicated at first, but it's not that complicated normally. So what is the appropriate way of doing it? Would be to write down a function that we use lapply. Now, the lapply normally is a function that builds this list automatically. So I explained that to you. Let me just put this down there. That you can see. So I'm going to do lapply, and this lapply I will take. It's a function that takes the different parameters. What are the parameters? First of all, we will have the variables PC that you have here, variables PC, and then you are going to apply a function on that. So you will say function, and then your function will take a certain parameter, let's suppose v, and there you will write something within your function. So what does it do is that when you are using lapply, you will build that list that you want here each and every time for each variable automatically by using this function that you will describe, and I'll explain to you in a moment. And it will apply it on this var PC each and every time. That's basically the idea behind. So lapply, what it is doing is that it is just looping over each variable name that we will define as v, and v is where v is in var PC. For example, v could be new month, v could be income MUR, things like that. It loops in there. This is what this function is doing for each d, that is for each variable. What it will do is that it will create one axis description with the label being the axis title and the values being the numeric vector. Now, to refer to the numeric vector, normally you will, in the list here, to refer to the numeric vector, you will say values equal to df underscore pc, and you would refer directly to that particular column V that you are referring to. And this is how you write this down, where you are saying that in the data frame PC, go and identify index V. That is, index V refers to income MUR, for example. So identify income MUR within the data frame, because V is a list of possible var PC. So in that list, identify in that list, find V, which is income, for example, and then income is going to be found in the FPC, and you will obtain the values from income MUR. So, so the values would be what you are going to get, that is a 0.17, etc., etc. So let's try to apply that. So I repeat, this dfpcv means that you take the column from dfpc whose name is stored in V. I repeat, you take the column, that is, you take the column through that here, you take the column from the FPC whose name is stored in V. V is a list already. That's why we put that square bracket, because it's a list here and we are referring to a particular index of V, which is income, for example, MUR. And this income MUR will be replaced here in the DFPC, and you will find DFPC of income MUR. So then you get the answer. You can't just put income MUR directly, because that would not work. You are using a loop, so you want it to be done automatically. That's why you don't want to include year, income, MUR each and every time yourself. That's not good. So how do we write this function in the end? So to write this function, what I will do, instead of typing dimension list as I mentioned to you, let me erase all this. Oh well, let me keep that for the time being in case I need to refer to that. Instead of doing list each and every time, I will say lapply directly. And in that function lapply, what I will do here, in that function lapply, what I will do, I will describe, as I said to you, var pc. And after var pc, that's not all. I will need to describe my function. My function will be function, I'm calling it the same name, function v. And in that function v, I'm going to have a curly bracket normally to enclose to include the content of that function. Now, what are we going to do here? We are going to just basically copy that thing here that I explained to you, but we'll do some changes to this. So the function, what it does need to do is that it will need to take the label being equal to v. The label being equal to v means it will go in the list that we have here, that is df, sorry, in the list that we have defined earlier, var pc, it will go in there and identify income MUR. So that's what it is doing. That when you say label is equal to v, so it goes and identify income MUR, then it will go for next one again and again and again. But for income MUR, it will need to seek the values related to income MUR, that is these values here. And to do these values here, we will need to write it down as you are seeing here, exactly as it is. Values equal to dfpcv. So what it is doing here is that it is populating a list instead of doing it one by one. So you are just applying that function lapply that will repeat that function for every v that is found in var pc. That's basically what it is doing. It looks a little bit complicated, but if you get the overall principle of what it is doing, it becomes straightforward. Okay, so here we go. I think that's all. We can just execute that. And by the way, I need to delete this. Let me just delete that and let's hope it works. So first of all, did I do the mutate? I don't know if I did it or not, but I will. So I need to erase that. Let me just run the whole thing again, just in case I did not run it before. So it seems that it is working everything. So to be able to know if it is working really, let's run fig because I define it as fig here. So we're gonna run fig to display the interactive bar chart. Let's wait a little bit. Normally when you are waiting in the meantime, you will see that there is when you are doing that, you will see that there will be a browser that opens that will be like what you are seeing here. Okay. It will be something like that. So what you want to do is the same interpretation that I explained to you earlier, but now you see that there are only two colors being presented to you. There is a yellow and there is the other color here, which is sort of different, sort of magenta. Sorry, I'm not able to differentiate the color clearly, but it is magenta sort of. But you've got the white, the gray, the yellow one, and this color here differentiates the different churns or not churn. Okay. Um, we can have some more information pertaining to what they are, but remember, we want to ensure that these are a little bit similar to what we have done earlier. I don't know if you recall earlier, we had income, then we did not have visit last year, we had spend last 3 months. All right, so we might want to shift that on this side. okay, to shift it on the side. That's what I do. You see how interactive it becomes when you do these kinds of thing. And then you may want to move Tinio on this side as well. And you get this interactive plot as you are seeing here. The next thing is that you would recall I was interested in this in let me just check if I got everything right here. So I was interested in knowing what about this individual uh, here, or this individual main here. Let me just check that. That's good. And I was interested in where is it? Yes, I think I was interested in that individual basically, and you might think that this individual relates to that in your months as well, but it's a bit tricky. So if you want to select only a group of individuals, you can do something like that. You can brush over this. So you can click on your vertical axis somewhere, and then you play around to brush. In other words, you will know what this profile refers to. So you see that there is an individual who has got a relatively low income with a low spending, but who has been visiting quite a lot with one of the highest visitors. And you will see that this individual would also be somebody who is part of, it's a bit difficult to identify again here, but is going to be having a relatively low tenure months. All right, he is someone who's relatively new uh, as a client, and it will be someone who is around a mid-level of satisfaction. So you can identify by brushing around the parallel coordinates to better understand what's going on. Okay, so that's a little bit what the what the parallel coordinate gives you. Unfortunately, you will see that there is no label necessarily for the yellow and the magenta sort of color. But because, as I mentioned to you, normally Plotly expects something like um, numerical variables. It doesn't expect you to do uh, this as some categorical variables, but still, if you are doing it, you'll have to guess yourself what these represent in that particular context here, because you don't have necessarily the information handy. Okay, that's for information how you can plot a how do we say an interactive parallel coordinates as you are observing here. Next, our next step now is to do the mosaic plot, okay? And then we'll do a 100% stack bar chart. So let's talk about the mosaic plot. Now, for the mosaic plot, I've already explained to you that mosaic plots are for categorical versus categorical association, and we wanted to see is churn, that is no or yes, related to segment, for example. It is a core, value, VIP, things like that. So we will start by creating the contingents table before we start even to draw the mosaic plot. We will need to do step one, is to draw the contingency table. I guess you already know what a contingency table is by uh, at this level, but if you don't know, I would encourage you to seek what a contingency table is, or you can search for two-way table as well, or a cross tabulation. That's the same kind of thing. Not the same kind of thing. That's exactly the same thing. Cross tabulation, contingency table. These are the same thing, and uh, two-way table. So there is also the n-way table as well for information. Then you will want to compute the within segment proportions, because when you're doing the mosaic plot, you have to do this because you are interested not in the row count but in the proportions rather. And the third step, you want to draw the mosaic plot, obviously. To to visualize the associations, if any, obviously. Now, the association, I'm not going to say association, but association rather, because there's only one, either it is associated or not, the two variables. So let's start by, first of all, creating our table, right? So we are going to create a table for segment and churn, where I'm going to put segment in the rows and churn in the columns, okay? So to do that, I will say, let me call the table seg churn, and I will say table, and I will use the original data frame that I've been working and modifying with regards to making them categorical. So here we go. I repeat, I want the um, churn to be in the column and the horizontal to be segment. So then if you want, sorry, I don't know why I'm writing church, but yeah, it's supposed to be churn, excuse me. Sorry, there has been a small issue with the um, video recording, but anyway, um, you will see that I've already executed that, and I've also executed that in the console here, and you will see that there is the contingency table given to you as you are seeing here. For example, among the core segment, there is a higher proportion of people who do not churn, and the same thing applies for the value and for the VIP segment. But for the VIP segment, the proportion of those who churn um, is only 8%, and not 8%, sorry, 8 out of 42, all right? Whereas here it is 32 out of 211, which is even far more smaller. So to better understand a little bit what's going on, maybe you would want to have these proportions, these numbers represented as proportions to be able to interpret. It's a bit difficult to interpret what's going on here. So what we want to do is that the same table segment churn that you have, we are going to copy that because it's v1, and then we are going to say prop.table. When we do prop.table, we are going to create the table in terms of proportion, and then I will say margin equal to 1. What does this margin equal to 1 means? Is that I'm looking at the probability that someone churn given that person is from a particular segment, just like I was explaining. So probability that a person churn given is from core is 18 out of 89 plus 18. For value, it is 32 out of 212 plus 32. So we want this kind of proportion to be presented here so that we can interpret better what's going on. So let's just run that. Here it is. We have here the value, which is 13%. This is 86%. Overall, there seems to be some kind of similarities in terms of the proportions by segment. There doesn't seem to be necessarily a huge um, association, all right? There doesn't seem to be a huge association except for this value, which is a little bit different. But from an overall perspective, there does not seem to be an association between these two, whether somebody will churn based on this segment. Okay, overall, I mean. So you can still confirm that, by the way, through a chi-squared test if you want to have a better indication of what I just said. Maybe I'm wrong as well. We don't know. We can just confirm this through a chi-squared test, and we just do that by doing chi-squared dot test, and then we are going to put the name of the table. For those who don't know what a chi-squared test is, I would encourage you to go and identify what a chi-squared test is. It will give you an indication of whether there is a significant association between the two variables or not. For example, here you see that the p-value is very high. So normally in a chi-square test, the null hypothesis is that there is no association. And the alternative hypothesis is that there is an association. Or the other way of saying it is that the null hypothesis is independent, that is, the two variables are independent, but the alternative is that the two variables are not independent. So in our context, given that the p-value is greater than 0.05, by the way, Each time a p-value is greater than 0.05, it means that we are not rejecting the null. However, if a p-value is less than 0.05, then it means that we are rejecting the null. In our context, as I mentioned to you, we have two variables, that is churn and segment. So the null means that churn and segment are not associated or are independent. There is no association between churn and segment. This is a null. And the alternative is that there is an association. But in our context, given that the p-value is greater than 0.05, we are not rejecting the null, not rejecting the null. So if we are not rejecting the null, it means that there is no association indeed between these two variables, that is segment and churn. If in case this has gone a little bit too fast for you, I would encourage you to pause the video and rewind and try to listen carefully to what I explained here in terms of a chi-squared test. Okay, you can just rewind and do it again. Now let's just run directly into the mosaic plot. To draw the mosaic plot, I'm just going to type mosaic. Okay, and then I will put the table that I've been working on. You don't need to worry. Normally, it will automatically do it in terms of proportion. That was just for us to better understand. So it will do it in terms of proportion, and then you can use things like shading. Shade equal to true. What is this shade equal to true? The shade is equal to true is used to show deviations from independence. Okay, that's the main idea. When you say shade is equal to true, it will indicate deviations from independence. You will see in the diagram later. Okay, and then you can put a legend is equal to true. What is this legend is equal to true? This shows a shading legend, because if you are talking about how these different cells deviate from independence or not, it's important that you give a legend to understand what the colors would represent, the shadings represent, I mean. And then, of course, you can have a title. So you will see that this is main, this is based our version, what you are doing here. So we'll do mosaic, and then we'll do segment by churn. Okay, I don't know why I'm writing this each time, but it's okay. So let me just fix that, and we run that. So let's just check what the issue is about. Let me just do that. You'll see that the graph is already available here in Windows. There's a graph at the back here, so you can click here and you will see that the graph is here. But unfortunately, this is unexpected because it was not taken into account that there was. You will see that there is no association at all in these variables. So the shading is not observed. Because of that, there is no association really. So this is why there is no shading that you can see or identify here. For example, you will see that all these different how do we say rectangles, there are many the same size everywhere, and it's not working properly. Okay, it's not working properly. So here there are some issues because of that, no association. All right, it's a graph where it's a data where there is no association at all. So if you want to deal with that, if you want to better see a situation where you will have um, a proper visual of what's going on, maybe we might want to how do we say, to create another fictitious data just to see you, to show you a little bit better what you could expect in a different example. Okay, so I'm adding something else which is not necessarily relevant to our data, something else where we will artificially create a table with some associations. Let me call it the same name, going to create a matrix here, or data frame if you want, it's okay. And in that matrix, I'm going to create values for core. Let me just show you that. I'm going to write it down like this. C for the matrix. Here we go. For the list that I want here, values, I would have, for example, 80, comma. Let's suppose I put 5 here. This is going to be what? This means you are talking about core being equal to 80 and 5 being yes. All right. So I'm going to create an artificial example just to illustrate this better. I'm going to move on. I'm not going to explain too much what I'm doing right now because to avoid taking too long. Uh, but I'm creating an artificial example. You don't need normally to do that here. This is just to illustrate an issue that appeared um, in our case where there was no association and you could not based on the VCR, because this is based on the VCR package and it did not work well. So just for information, this is some of the limitation that you have. So this is for core, this is for VIP, sorry, for value, this is for value 40 and uh, sorry, this is 18 no and 40 no and 40 yes. And this one you would have understood what it is. I'm just going to move on and we are going to do this by n row equal to 3 and we are going to do by row equal to true. You don't need to worry about what I'm doing. I'm just uh, creating a fictitious example. This is just for your information. I'm not going to explain this part here. What I'm doing, I'm just going to move on and then I will give the row names of the column of the matrix because right now there's no row names. There is only 1, 2, 1, 2, 3. So I'm just going to go and give a row names. I've already done it elsewhere. I'm just going to copy and paste these names directly so that I don't take too long. I'm going to put the row name, column names. So the row names will be core value VIP and column name. So now if you do this again, you will see that you get a proper naming rather than 1, 2, etc. So that's one thing. And then you can do chi-squared test just to check what you get. In this particular example, you see that the p-value is far less than 0.05. So drawing this diagram will be a good idea because we expect to get something interesting out of it now. So for that purpose, I'm going to write mosaic and then put the name of a table and do the same thing, shade equal to true, and we are going to put the legend for the shading equal to true, and then we are going to, and here I'll give a title as well. You can put main, but I'm just going to move on and show you what you get. Here we go. Now it works properly. You will see that when there is a value that is gray, that indicate that there is not much association with respect to value between churn and not churn. Whether somebody will churn or not churn does not depend on the value, as you will see, but it does depend on the core segment and the VIP segment, as you are seeing in this example. So the more red it is, the smaller the proportion, the bigger it is, the more, when it is blue, the proportion will be bigger, as you are seeing here. The residuals, Pearson residuals. I'm not going to get into that right here. But when you are seeing a big difference in shading like this, it indicates clearly that there is an indication of association going on within that data. But as long as it is close to zero everywhere, let's suppose everywhere is close to zero, that indicates that there is no association between the different segments, but also overall. Like here, overall, there is an association, as you can see from the graph itself, but also from the p-value as well. That's just for information. Unfortunately, the data that I gave you did not include this association, so sorry about that. But still, I just showed you an indication of what you can expect from this, okay? The last thing I want to do is a stack bar chart. By the way, there is also a way of drawing a mosaic plot directly in without the VCD package. For that, in base R, you can just type mosaic plot, and then in mosaic plot you will put the data that is of interest. For us it is a table that we have worked on, and then what else can you put in there? For example, you would say shade equal to true, but it's not the same kind of shading that you are referring to here. That shading will be a little bit different pertaining to the churning, for example, and then you will say legend is equal to you will say no, not legend is equal to true because there is no legend here, but shade is equal to true. That's all, and then you can put main if you want. You can just execute that and see that it gives you something like this. You get the standard residuals, and there is a legend as well, but there is no need to put the legend is equal to true. Sorry, that is mosaic plot from the base version. You get something a bit similar to what we have done, but with the labels and so on, as you see here. That's the base version of R, which is not bad as well, which is also very nice. So, but it depends if you want to use VCR, you can VCD. Sorry, you can use VCD. Otherwise, you can the VCD package. I mean, otherwise you can do the base version mosaic plot as well. Okay, that is for base version mosaic plot. Our next step now is to do the 100% stacked bar chart. Okay, we end this on 100% stacked bar chart. That was just for information. I'm going to erase that, or because it's just the data, you can focus on the video interpretation directly, but this is just for the purpose of explanation. I'm just going to erase that to avoid any confusion, and I keep it just for you to know that you can do it otherwise. So let me do the 100% stack bar chart, and then we end that first part of the second part of video. So we are going to do the 100% stacked bar, which is the conditional proportions that I explained to you earlier. How are we going to do that? We are going to use the ggplot function. This one is relatively easy. So we'll use a ggplot function directly, and we will include our data frame, which is df, via static features. For this plot would be x is equal to segment, that is we want the variable, the horizontal axis to represent segment, and we want the fill to be equal to churn. When we say fill equal to churn, that means the bar is split into no and yes parts, okay? And then we want at the end to add some additional information, which is the geom bar, because we are doing a bar chart as usual. And then we will say position fill, which means what? Position equal to fill, which basically means that you are rescaling each bar to 1. Okay, when you do that, position is equal to fill, it means that you are rescaling every bar to 1. That is, we are rescaling to 100%. giving proportion instead of count directly. All right. So if you did not put the position field, it will just create count as usual. And but we don't want that. We want it to be this position field to be included to get this stack bar chart because we want a 100% stack bar chart. And then let's try to run that for a moment. There we go. We get this stacked bar chart. And then you might want to change that format of the vertical axis in terms of percentage instead of working with 1 0 because we don't want this to be count as well. We want to change the label as well. So let's just do some additional fine tuning here in this example. So to change the vertical axis, we will use this y underscore continuous function in ggplot, and that function here will be used to add labels in terms of percent format rather than using the correct format. So this function y scale, what it does, it shows the y-axis as a percentage. That's basically what it is doing here. When I'm doing this thing here, I'm doing basically what I'm doing is that I'm showing the y-axis as percentage, and then I would do plus and add the lab and change the labs accordingly. I'm not going to change all the labs here. I'm just going to change the main ones. Plus, for example, you can add the title. I'm not going to add a title here, but you can say x is equal to segment, y equal to proportion or percentage, rather, and then you can say fill equal to churn. Fill equal to churns mean you are going to differentiate the bars. Okay, you're given churn, small c churn here, but you can do that to change the fill information. And then you will see that you have theme, black and white that you want to have. And here we go. Where is it? We execute that, we get some changes. So this has become to C capital, and then you get all these different things, and then you can again you can use theme classic if you want. Execute that. Sorry. Theme classic will remove all these things, grid lines and so on. So here we go. We get a 100% stack bar chart where you will see that the percentage of those who churn seems to be a little bit lower in the value segment compared to the other segments, but there doesn't seem to be any association at all. Here we go. That's all for this video. For the next video, we are going to go a little bit faster because I'm just going to go and show you the technical side of how to run the Python code. That's all, without getting into much details with regards to the interpretation and everything. Okay. Thank you for your attention.